And welcome back to the Windows Phone 8.1 Developer Jumpstart. I'm Matthias Shapiro, and I'm going to be talking about universal apps for Windows. That is what this session is about, and we're going to do a little bit of a deep dive on how to build our universal applications and how we use Visual Studio to drive those applications, and what sort of patterns we're going to use to build applications that are flexible and reusable, and most importantly, converged and shareable. So we're going to do a bit of a universal apps overview. A lot of this is going to be sort of remedial because we've been talking on and off about universal applications this entire time. But I'm going to show a little bit of convergence summary. I'm going to show how we can take existing projects and turn them universal. And then we'll talk about code sharing strategy, and I'll show an application that has a universal shared application with a PCL and explain what the application is. Why did we put this piece into the shared and this piece in the PCL, and just what's a good architecture for creating the most reuse in our code and the most convergence in our apps. So the Universal Apps Overview. Welcome to Universal Apps. If you're just joining us, Universal Apps. Where have you been? Right. This is a very odd time to just join us at session 23 or 22 of a 23 session Jumpstart. Universal applications are applications on the converged Windows 8.1 and Windows Phone 8.1 platforms. We've been talking about C# this entire time, but you can also build converged applications in C++ and XAML, or in JavaScript, or in C++ without XAML. The easiest way to get started with these converged applications is to use the Universal App Projects templates, and but you can also add a Windows 8.1 application to an existing Windows Phone application, or a Windows Phone 8.1 application to an existing Windows 8.1 application, and that'll give you pretty much the same template, the 2 application projects plus the shared project. So how converged is Windows? We've been talking a lot about convergence. We've been showing a lot of convergence. But in fact, there is this massive convergence. This is just a diff of the APIs between Windows 8.1 SDK and the Windows Phone 8.1 SDK. And I completely stole this slide from Tim Pure, who showed it off at Build 2014. But because it comes from Tim, I'm pretty. I feel it's a pretty reliable chart. And the fact of the matter is that the vast majority of the APIs are converged between Windows and Windows Phone. Well over 90%. It's well over 90%. And the ones that aren't converged are largely APIs that have this very specific intent for use on phone or on Windows, or in some cases there are APIs for Windows that are basically kind of resource constrained, and so they would have to be resource constrained if you move them over to phone. So for the things that aren't converged, there are actually a lot of reasons behind that. So if we have an existing project and we want it to convert it to universal, this applies only to Windows 8.1 projects and Windows Phone 8.1 projects. If you started out with a Windows 8.1 project and you want to add phone, or you started with phone and you want to add Windows. And
we have to remind everybody that when we're talking about Windows Phone 8.1 here, we're meaning WinRT XAML apps.
Yes.
Not Silverlight.
Yes. Yes, there is not a shared project between Silverlight and Windows 8.1 applications. But we can right-click on that application and go and add Windows Phone or Windows 8.1. If we have API differences that we need to navigate, we can navigate those using the if compiler conditionals. If you've been watching this whole time, you've probably seen us use this a couple of times to sort out little differences between Windows and Phone in the APIs. The compiler conditionals, for the record, for Windows, it's Windows_app. For Windows Phone, it's Windows_phone_app.
And actually, these are defined. You go into the project properties, you can see under the, what's it called, the compilation tab.
Like the build tab.
The build tab, You can see compiler conditionals are defined in there. So new project templates have these already baked into them.
Yep. And so a great example of where you might use this is the hardware back button is Windows Phone only. So if you need to do something, if you need to hook into that hardware back button and maybe preload some data for the last screen or do something like that, then you're going to have to wrap that inside of an if compiler conditional, and that's where you're going to put your back button event handler, so you're not breaking your Windows application. So I'm going to actually walk through the process of taking a Windows 8.1 application and converting it to a universal app. Wish me luck. There we go. Okay. So here we have our Windows 8.1 application, and I'm going to run it real quick. I say that a lot. I'm going to run this so that you can see. Oh, I have a. Do I have something already running? Let's close you down. Rebuild the application, maybe?
That looks better.
There we go. Okay, so we're just getting a couple of pictures off of our pictures.
So, for some inconceivable reason, you want a phone version of this awesome app?
Right. So, for phone, yeah, okay. I got my phone's plugged in. Good. Okay, so this is pulling from the pictures library, and this is a demo machine, so we haven't saved a whole lot of pictures in there. I should have done that before we started, but we just want to pull the pictures, and we want to look at all of our pictures, and we can actually, inside of that application, which is now gone, we can tap on the picture and see a bigger version of it. So I'm going to right-click here, and I'm going to go to Add Windows Phone 8.1, and it tells me it's adding a Windows Phone 8.1 as shared project. And so now we've got our Windows 8.1, our shared project.
There's nothing in the shared one.
Right now there's nothing in the shared one. So I'm going to grab my view model, models, and common information. I'm going to dump that into my shared project. I'm going to take my main image and my image view, and I'm going to dump that into my shared project. I'm going to get rid of my main page here, get rid of this, and this, and these, after I make sure that all of the files came along with them. Yep, looks okay. So
that's because you would end up with them duplicated, because if it's a shared area and in the head, then you can't have the two files the same in the same place.
Yeah, because the way that the shared project works is it just takes these files and it moves them into both projects at compilation.
In fact, this shared fault project is exactly this. It's a new way of doing adders and link. If any of you have used that before, it's like you've got a common folder, you stick some files in there, and the old way of doing this would be you'd add existing files in as links rather than as actual physical copies. So, and this is a new way of doing the same thing.
Right. So I'm not going to move the app.xaml because this is a demo, but I could. There are a couple of little things in app.xaml that are going to be Windows Phone specific or Windows specific, but honestly, you're also going to see those if you just open up like a new universal template, a blank template or the hub template. All that stuff will be already if conditionaled for you, so you can kind of take a look at what a shared app.xaml might look like. Okay, so we're going to go and set our startup project to phone. We're going to use the device. I've got my happy little shared screen here. Run it. And
XAML pause exception.
Oh, okay. Well, let's go ahead and open up our main page and see what that might be. If you were here for our...
I have an idea.
Yeah. If you were here for our previous, for the tooling session, you'll know that one thing that we can do is we can actually open up a XAML file, and change the context of that XAML file to be either Windows or Windows Phone. And then
you can do this with anything that's in the shared folder. This is one. Effectively, this file exists in two projects.
Right.
It exists in your Windows head and also in your phone head, so you can see, and stuff will be, some stuff will be valid on one.
And here we can see this is what we're missing. We're actually missing our data context because we had defined it in our app.xaml and we hadn't moved that over yet. So we can grab that and toss it in our app.xaml along with the namespaces that go along with it. And I've got local in there twice, so we'll get rid of that. Now we run it again, and we should have that resource resolved. And in fact, we do. And here is my incredibly blank pictures. The reason that it is blank is because we've been pulling from our pictures library, which is a great place to pull if you are a desktop, but not such a great place to pull if you are a phone. So we're going to use our compiler conditional here to say if you're a Windows app, pull from the pictures library. But if you are a Windows phone app, pull from the camera roll. And just like in our XAML, we can change the context of our IntelliSense with this, this handy little toolbar up here. So you see that our code colors go live depending on which context we're in. And am I missing something here? It looks like this is not loading up for some reason. That's sad.
Do you want to just make the font a bit bigger?
Oh, I'm sorry. Yeah. There we go. Image library source. The data context should be there. We should be. Everything should be working, and yet it is not. So for whatever reason, that doesn't seem to want to run, which is strange because we literally showed this exact same application in the last session, and it was working delightfully. So that is that's a great thing about that. But I'm gonna show one thing here. This is kind of fun. It actually runs in the off of the data, our pictures data, inside of the designer for Windows. But you see that when we have our Windows application, the My Pictures looks fine. But we can see that it's all cut off when we're using the Windows Phone version. And this is kind of fun because this allows us to show off our device pane, which will open now. Okay. The device pane allows us to switch devices within the design area. So we can go and see that at certain device sizes, this might look fine. But at smaller ones, it's going to look poor. And this is a lesson in adaptive UI. You see, our row definition is not designed, is set to a proportion of a screen. And so it's not going to resize itself to fit the area that the My Pictures element requests. So if we go and set it to auto instead, now it is. Now it's no longer cut off. And we have a design that's going to work on our small screens as well as one that's going to work on our bigger screens. So I'm trying to think what else I was going to show along with this. I showed if you go back to diagnostics and tooling, I was showing off some of the XAML opportunities that we have inside of Visual Studios. And so I can run over that again, but I don't think it's probably not a very good use of our time since it's already in session 20. So if that had been working, I really want to know why that's not working. I'm sorry. I'm actually not too bad on time right now, so I am gonna Okay, so we've got our, it does go to load images. It hits the folder.
You've got the capability.
Oh, there you go. There you go. I wish I should have been throwing me an error on that, shouldn't
I
it?
should have got an exception.
Okay, I should have gotten an exception for this, but I wasn't getting it. Okay, that's right. We need to go here and check our pictures library. I'm going to go ahead and check videos as well, because our app package our package.app manifest is not shared between our two applications. And so this means that
it's like lack of try-catch going on there as well.
Yeah,
perhaps.
maybe a little bit.
Swallowed exception stuff going on there. This is a case study in poor programming, I'm afraid. Yeah.
The other demo's better. Okay, now if we run it, we'll see it hits all of our touch points, and we still don't see the on property changed images. Add image. Okay. I'm not 100% on this right now. Then
Right.
if it's not going to be doing that.
Yeah, nothing to see here.
Right.
See here.
What on earth? Okay, we're gonna move back.
Yeah.
There's a thing with this, but come on toolbar, you can do it. All right, we're just gonna alt tab our way back here. So I mean, hopefully, what you saw with that demo was that it was very easy to create a new application, to pull all of our files there. Now, maybe if you wrote your application better, it would work a little bit better. But it's easy to debug. You could see we were running all of the same code. We were running all of the same XAML, and it was as easy as grabbing it and just kind of dragging it over. As you can see, there are going to be these little pieces. You probably are going to be missing some resources, especially if you're using the system resources. But the good news about that is that there are also, and actually I am going to show that piece because I do have time. When you have a piece of XAML that is in your shared project, and you decide that you want to give it a style, you start your application. The IntelliSense gives you controls that are stylable across both platforms. I think. I don't remember body text blocks out. No, okay, yeah. So all of the styles that you see here in the IntelliSense are things that are going to work on Windows and Windows Phone. Okay. So code sharing strategies. This is going to be all new stuff. There are a lot of different ways to share code in Windows 8.1 and Windows Phone 8.1. The big one, the one that we've been talking a lot about because it's the easiest one and it's really effective, is that shared project files. There are very few restrictions on what you can put into the shared project files. It accepts most file types. You do images and assets and localization files and XML. Pretty much everything, and that's because it just goes and grabs that and sucks all of that data, all of those files into both projects. Another way we can share files and libraries is through a portable class library. This way we can share both libraries and Windows runtime components, and I'll show the ways that we can do that. And the last way is to use add as link to share files. Now, this is a particular use case that I'm going to call out because this doesn't make a lot of sense if the only thing we care about is universal applications. If we're only doing Windows 8.1 and Windows Phone 8.1, add link doesn't make as much sense.
Because
because it's the same
as the shared
we've
project.
been doing that already.
Yeah, and actually, but I think you're about to say, if you share code with like a Silverlight app, for example, then add as link starts to make sense because you cannot have a shared solution with a Silverlight project and a WinRT project and a shared folder. That isn't going to work.
Right. So the shared project, I said this already, and we're going to say it again. Shared source between converged apps. It has no binary input, and it supports all types of items. Shared XAML components. So if you have a XAML component, It's cross-platform XAML. You can use the Visual State Manager to handle some of your layout changes. This is a very, very simple version of how you might do something like that.
It's an interesting one, this, isn't it?
Right.
Because actually, if you create a hub project, or use the new project template, you create a pivot. Sorry, we're talking about universal one. So you create a hub one, for example, which is a fully functioning, rich application. The new project templates will give you all your XAML files. It will duplicate them. It'll have one version for Windows and one version for Windows Phone, and that kind of makes some sense because they are going to look. You're going to create a different user experience on a tablet than you are on a phone. They're different size screens. They may be used in different orientations naturally. They're obviously different sizes. So what you're going to show on the phone app compared to your tablet app is going to be, this is it. You're going to tailor it. We recognize you're going to want to tailor that user experience to make the most of both of these platforms.
Right.
So having two separate XAML files, one in each head, is the easy way of doing that. But you are duplicating some stuff. So what you're saying here is actually just have XAML files once, put them in the shared folder, but then handle those differences in user experience in a different way, which is this Visual State Manager.
Right. Yeah. And so the Visual State Manager, you don't have to create a Windows and Windows Phone Visual State. In fact, we don't really recommend it.
It can get complicated.
It can get very complicated. Yeah. Right. But this is I felt that this was a really simple way of kind of explaining the Visual State Manager, and we're actually going to see. I use this for demo purposes in the next demo, so we'll look at exactly how that's done, and then. You could switch between your states in the code behind of your XAML file and simply say, okay, if I'm in a Windows app, go to the Windows Visual State Manager. If I'm in a Windows Phone app, go to the Windows Phone State Manager. If you want more information about doing adaptive UI, something that's a little bit more comprehensive than a simple Windows Phone binary switch, check out session 6 on adaptive UI for differing screens. Portable class libraries for Windows. If our portable class library is just targeting our Windows Universal application, we can actually support WinRT APIs, the Windows Runtime APIs.
Yeah, because this has been an interesting technology for a few years.
Yep.
But up till now, you've only been able to support .NET APIs. So it's kind of been interesting, but the use cases have been a little bit narrow. But now with this one, they've got the whole WinRT APIs available if you target Windows 8.1 and Windows Phone 8.1.
Right.
Clearly, if you throw Silverlight in there or .NET Framework 4 as well.
They're going to constrain back down there.
Every time you add a new platform into the supported list for the PCL, you're narrowing the cross, because it just supports the cross section of APIs that are available on all of them. So
So, but it's still a decent way to do libraries if you have a library that you really want to use across multiple applications. If it's just one application, the PCL doesn't make a whole lot of sense. If you're building a library for cross application development, then it's really starting to make sense to build your...
And a lot of devs, you'll end up, if you're building apps for any period of time, you end up with kind of utility classes and common stuff that you use over and over again. And it kind of makes sense maybe to build that out in a PCL that you can just pull in and reuse over and over and not have to kind of copy and paste code around.
Exactly. One very cool element that has been introduced to PCLs is that you can go into your PCL properties and you can select an output type, and you can select a Windows Runtime component. And what that means is that you can expose those libraries. You could write in C# and expose those libraries to a C++ application or a JavaScript application. And so all of a sudden, the PCL that you build one time doesn't just span multiple projects; it spans multiple coding scenarios. So I think that's pretty exciting. It seems pretty cool. But we can also use portable class libraries for broad targeting of Windows Phone 8 and .NET frameworks. But as we said before, you see in my image has changed so that I'm now targeting .NET Framework and Windows Phone Silverlight 8. But that's going to constrain our API set. It doesn't make it useless, as we'll see in a minute, but it does. We're going to lose the ability to do Windows Runtime APIs. And then that last one, add as link. You can, if you want to add a file, you go through the normal add dialog, and then at the very end, there'll be an arrow on the button, and you click on that arrow, and it gives you the option to add as link. And every add as linked file every linked file will show up with this little blue icon on it. And if you're using this across, for example, a universal application, maybe a Silverlight 8 application that you're still supporting, you can use compiler conditionals to share across those two platforms. So the code sharing architecture, I have dumbed this down in the interest of, so I am an MVVM fanatic, and I've done tons of talks on MVVM, and I love using MVVM, and I didn't want to dive down that rabbit hole because we could get lost for hours talking about it. So the very simple version of code sharing architecture is that we want to keep in mind our separation of concerns. We're trying really hard to decouple our UI from the logic that drives our application. So in a very simple, general way, the UI will live in our Windows and Windows Phone projects. This isn't every single UI. This isn't all the time. But generally speaking, our Windows is going to have a different UI than our Windows Phone. And so it makes sense to have that XAML, the XAML pages for Windows in the Windows project, and the XAML pages for the phone in the phone project. We're also, if we have some platform-specific API sets, something like geolocation or media or sensors that has a very specific application in between the two platforms, it might make sense to put those files in the project-specific folders. But the logic should, generally speaking, live in the shared project. Like I said, there are a couple of exceptions to this rule. But if you find yourself building all of a lot of logic in your Windows 8 project, copying the code and pasting it into Windows Phone, that's probably a pretty good sign that that file could more effectively live inside of your shared folder. It's also a good place to put XAML components that make sense. XAML's a great platform for building these componentized UIs and sucking those components into our pages to do specific things. And if that's how you build, bravo for you. That's great. You might want to, thinking about making your XAML components cross-platform so that you're only building them one time is a great idea. So we're going to look at a universal application with a PCL. And this is going to be interesting and fun. Okay, we're going to make sure this runs first before I have us switch the camera. Okay, switch the camera. So this is a what we call the Hue lights, Philips Hue lights, and these lights are Wi-Fi enabled, and you can control them using. So I control them with a Wi-Fi bridge. And what I have here is a Hue lights enabled application, and I can change the color of my lights, and I can change the brightness of my lights. If I can get these brightness all the way down, and so you can see that this is a nice kind of fun way to play with the lights in my home using my my Windows tablet.
These are Wi-Fi lights.
These are Wi-Fi lights. Isn't that radical?
Pretty awesome, that, yeah.
So you can see I've got. It looks like I've got something that would work pretty well as a component, right? It's the same thing 3 times, all the same controls. And we've got some cool bindings. Let's jump in and look at what that component looks like. I have too many things open. Okay. So actually, let's put that component off for a minute, and let's actually look at what this project looks like. Okay. You see I have is, remind me how to do zoom on, is it Alt, Windows Z? Okay. Control Y. Control 1. Windows 1. No. Come on. This is just my day. Okay, so hopefully you can see this. I wish I could zoom in on it. My mind is blanking on what my zoom key is. But this is a universal application. It's got a universal Windows Phone, Windows application, a phone application, a portable class library, and I'm supporting a Windows Phone Silverlight 8 application for all the people who are still using Windows Phone Silverlight phones, like my dear wife. So, what did we put in where? I want to start with PCL. because that's kind of the lowest level of APIs. This PCL is being used in my Universal application. It's being used in my Silverlight application. I've got some helpers in here. I got some mathematics to change RGB to hue and saturation numbers. I got some models. These are models that represent my Hue Wi-Fi bridge and my Hue lights, so that I can just use those objects and interact with them. I have this service, and this is using the HTTP client library for portable class libraries, and this is all of my communication. Every piece of communication that I have with my Hue API is inside of here. Everything from user registration. Everything from user registration to connecting to the Wi-Fi bridge to communicating with the lights themselves. Everything is inside of this service. And then I can put some view models in here. I don't have one, but I could put view models in here and share those across my applications. But instead what I've done is I've actually put my view models, which are driving the vast bulk of my logic, inside of my Universal application. Let me open up my client view model, and you can see this is a demo application in the sense that I use it for demos, but this is a very serious application, right? We've got a lot of properties. We've got commands for updating all of our different lights. We've got commands for cycling our lights. We've got update commands so that if I'm using this application on multiple devices, I want both devices to keep up to date on what the color of the lights are, so that they'll update automatically if I change it on a different device. There's a lot of stuff in here, but it's stuff that I don't need to worry about sharing, because everything here is business everything is business logic. It's easily shared between my Windows Phone and Windows application. I've got my some converters, a Boolean to visibility converter, a pretty nice standard converter for people who've been in the XAML space for a while, along with my reverse Boolean to visibility converter. I got some color converters, which are just helpers for my my Hue classes. But the thing I want to look at specifically is this Hue light control. I'm going to open this up. And actually, the best place to open this up is inside of Blend. Which has apparently never been opened before on this machine. So we're going to build this in Blend, because sometimes we have to do that to get stuff to show up. This really kills my use of Blend here. That's devastating. Okay. I wonder if it's too late to Wi-Fi bridge into to go into my other application. Oh gosh. Okay. Okay. Let me show you what we're doing with the Visual State Manager here. Here we have a Windows and a Windows Phone Visual State Manager, and I really wish that this was running, because inside of Blend, you can actually select that visual state, and it will show you exactly what that component will look like inside of that visual state. So what would have happened if I could go into Blend is I go into Blend, I'd select the visual state with the UI that you saw in the presentation, and it would show me this is what it's going to look like when it's on Windows Phone. This is what it's going to look like when it's in Windows. And what I actually have end up doing is on Windows Phone, I don't have all that space for my light at the top, and so what instead I've done is I've taken out the text at the bottom, because it's just going to be too small to read on a phone. I move the light back behind the control because it's not interactable. We don't really need it to take up that much space on the phone. And then I shift around the space for the red, green, and blue indicators. And so then my control looks different on Windows Phone as it does on Windows. It's specifically designed for the platform that it's on. Now, why didn't I move the main page.xaml into that universal shared platform? The reason I didn't was because I'm using a pivot, and it's just a great way to control these images on my Windows Phone application. I may have that installed if I can. I don't have to run it from here. You just pull it up so we can see it. Nope, not gonna work. All right, that's fine. Okay. I actually have an example of what. Okay, so this is the phone UI that you can see here. It's not connected, it's not running, but at least you can see what's going on. And I can move in between all of my different lights, and I can control my lights in a way that really makes a lot of sense on the phone, and the pivot control is really well suited for. But we don't have a pivot control in Windows 8, and so we have our own main page, page.xaml application or file, and inside of that we have the same thing, just the three hue light controls. The three hue light controls, and all we have to do is set the data context on each one and listen for an event handler, the light changed event handler. And every time the light changes inside of the control, it's going to run that event handler, and we can hook into our view model, send that message out, and change our light. And one more thing, jumping back to the hue light control, that I wanted to point out is that here is that Visual State Manager go to state that we saw previously. Just as soon as I initialize the control, I go and I look at the state of that. I go and I say, okay, where am I? Am I running this control from a Windows application or from Windows Phone application? And pick the appropriate state manager for that particular scenario. And so that covers the why we put stuff in the shared file, why we put stuff in the portable class library. And I want to touch just briefly on that linked file. So I actually am sharing my view models, the view models that I have inside of my shared folder here in my Silverlight application. And when I go into my Silverlight application, I can open those up. You see, I'm using a compiler conditional to manage just a couple of UI or a couple of namespace differences between my Silverlight application and my Windows application. And you can see that, yep. And so that's really all it took. There are a couple of differences there. There are some dispatcher differences between the Silverlight model and the Windows runtime model. But for the most part, we've got a view model that's driving a fairly substantial application. Well, a reasonable little application. It's a toy. And we're sharing all of that logic between not just our Windows and Windows Phone applications, but between our older Windows Phone application. So this is going to make maintaining the application across all these platforms much, much easier. And because I have been, because my demos have been running so poorly in this presentation, that is all I have, and we're actually a little bit under time. Oh, so, right, catch up a little bit there.
Yeah, cool.
But so it's a universal application, or universal and shared projects, PCLs to drive some more abstract parts of that application. And shares link to help bridge the gap between maybe older or more diverse projects that we might have.
Cool, great.
Coming up next is...
So we're nearly at the end of the Jumpstart. We've got one to go.
Okay.
And the next one is going to look at topics specifically for Silverlight developers, about Silverlight 8.1, about retargeting your apps from 8.0 to 8.1, and from some of the issues or the ways that you have to program around using some of the WinRT APIs. So please join us for that.